So after Chapter 1, the introduction to this whole semester, Chapter 2, if you'll remember, took a chronological sweep through time looking just at the early history of recording technology. Chapter 3 went back in time and did a chronological sweep again, looking at the developments of early electronic instruments. And then Chapter 4 kind of stuck at the end of that period so that we could look at the launching of the first research facilities, the studios for electronic music and some of their techniques. Now we're going to take a look at the transition from analog to digital technology. And this is something that impacts the research facilities as well as consumers, the creators and the audiences. The first thing, and happens to be the last thing the author wants you to remember as well, is that when we talk about the transition from analog to digital, it's not that analog is completely replaced by digital things. And the truth is, as the author points out, that we still need some analog technology. Microphones and speakers are analog technology, for example. We may find a microphone or speaker that says it's digital. What that means is that it has a digital, analog to digital converter attached to it. So it's really a microphone plus this converter so that it can send out digital signals. Or the speaker has a digital to analog converter connected to the speaker so that it can accept digital signals and convert them to analog. But in their basic nature, a speaker and a microphone are analog. So why haven't we replaced microphones and speakers that are analog with digital versions? Is that possible? Not without a lot of other things changing too, and that's maybe a little creepy. We need devices like this. We need a microphone to take the physical vibrations in the air, the changes in air pressure, that is the sound. And they convert them first into a voltage, and that voltage can be converted into data. That's the digital signal. So it comes from the physical to the analog, and then that gets converted to digital in a digital system. On the opposite end of it, a digital signal comes out of the computer. It needs to be converted into an analog signal so that it can tell the speaker how to move back and forth. This is just done by varying voltage, varying electrical charge. This is an analog of the digital signal, and that speaker takes the varying voltage that is changing in analogously to how the digital representation of our sound was changing, so that the speaker can move back and forth and in turn move the air so that it's creating the same kind of vibrations that were heard at the time of the recording. And we need those because they can interfere. That's how our ears work. Our ears don't have a digital connector. They don't have an analog electrical connector. They have the air, and so we need those vibrations. And so the analog is, if nothing else, is an intermediary step that's necessary between the physical world and the digital world. Now, it's going to be important to have some understanding of what we mean when we're talking about analog and digital, since now you understand that analog doesn't necessarily mean old and out of date. So think about clocks. We've seen analog clocks and digital clocks, right? And so an analog clock might look like this if we zoomed in on it. And let's see, we might have a hand moving like that points to the time. On the other hand, a digital clock looks something like this. And it's 12 o'clock, and it stays 12 o'clock. It's not moving. It stays 12 o'clock, and it's 12 o'clock, and it's 12 o'clock until it's 12:01. And then it stays 12:01, and it stays 12:01 until it's 12:02. So this illustration shows the two things you can remember about analog and digital signals. An analog representation is continuous. See how on my clock here, I can have, this is where it's 12 o'clock, and right there is where it's 12:01, and I can have it be 12:02, or I can stop it right when it's 12:01 and a half, 12:01 and a quarter, 12:01 and a tenth. There's infinite ability to divide it down, whereas a digital representation, it's represented in digits, or whereas we say an analog representation is continuous, a digital description is discrete. It's either 12 o'clock or it's 12:01, and it has a distinct resolution to it. You can also remember how a digital representation is discrete because the word digit means that it's represented in numbers, or for a computer, they're basically interpreted as words. Information about the time is written down. It's expressed in digits, and the digits have to end at some point. That's why we have some limit to the resolution. Whereas with a continuous representation of time, this clock has no idea what time it is. It's just pointing. And really, even less than that, it's just moving continuously in parallel with, analogous to, the movement of time throughout the day. So an analog representation knows nothing about itself. It's saying nothing about itself. It's just literally an analog, an analogy of some other physical phenomenon. Whereas the digital signal is a discrete representation where it's analyzed it, decided what it is, and it's written it down. That's going to become important later. So watch this next video now that we've done a basic description of analog and digital representations. This video will talk about analog and digital signals and what the benefits are of using a digital signal over the challenges that we've dealt with for almost a century for dealing with analog electronics alone.